So finally I have done the exam, so I can do hard problem because I'm not in a hurry. So a virus. Virus is spreading rapidly and your task is to quarantine the infected area by installing walls. The world is modeled as an m times n binary grid is infected. Okay, the wall can be installed in what? For any two 4-directionally adjacent cells on the shared binary. A wall and only one wall can be installed between any two 4-directionally adjacent cells. Okay, on the shared boundary. Resources are limited each day. There will never be a tie. Use the quarantine. Okay. So how big is the board? 50 by 50. Return the number of walls used. What the hell? So how you choose if there are multiple regions? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 by 3, so it's like some 3 by 9. You got this shape and then a line, so the region on the left only builds 2 new walls. What does that mean? That threatens the most uninfected cells the following night. Okay. So you just have to simulate this? I mean, it's 50 by 50, so I mean, then I guess I just simulate it. What can I do? I guess. Will it be non-empty? Yes. Okay. That's a very long name. Okay, so after we grab that, do I vector of vector This is gonna be so bad. I mean, I guess you just pick. I could have a struct which could be called like component which will have the number of infected cells. For a vector pair int, let's call it cells, then we make some private method which is gonna be called components, which return vector compo while comp let's say while I mean I could calculate the walls also, so I get vector of components, and while not comp empty so I want to do sort components begin components end, and then I want to have some lambda function which compares them, but I probably can have auto C1 C2, and we want to return C2 threatens C1 threatens, so that I get them ordered by the whatever. So the first one is first, C components 0, and then so after we take the component, we wanna update the answer C walls, and then what we want to do is I mean, do I really need the walls? No, not really. I just need an int, and then for auto, let's call it like const const auto p in something in C cells, and a p first p second is equal to to 2, and I guess that's it. I mean, technically I could just spread out the components, but we will see about that later, and then we just return answer. Okay, so after we done this, well, if this ij continue, and then I don't understand why is this gonna be so hard, because you are gonna get at most 2500 regions divided by 2, so only like 1250 regions. And even if you iterate for some reason 200, it will still pass if I make like n squared m squared. That is weird. Otherwise, I don't know. Let's do a Q. Q, and now what? Was it front, or I have no clue. I should maybe say what I'm doing, but I mean, I'm just running a BFS from every unvisited, like I just go through this and check up on them, and if this is not visited, if it's visited or it's 0, then whatever you skip, and if it's not 0, if it's not 1, because we are gonna mark 2 with the already enclosed one so that they don't spread. And for the current component, we want to count the number of walls also, which is also the number of positions it threatens. Not really. So walls is just number of neighbors, but I need some sort of threatens, I guess. So I could do like unordered set of ints threatens, because this is 2 walls but threatening only 1 position, so this is important. If we are inside and a new I new j is equal to 0, then, and it has to be, and no, we are inside. Now, if a and y and j is 0, then walls plus plus threatens insert ny times m plus nj. So what I'm doing, instead of, I cannot store pair in a hash set, but each cell has a unique number, 1, 0, 1, 2, 3, blah blah blah, and this is m plus 1, m plus 2, 2m plus 1, blah blah. So I solved the problem. Else if the new cell is 1, maybe, then and not visited, that might work, and then we do visited and q push that pair, and I guess then we do answer and into answer we need to have some sort of visited, so pair int sales push back ci cj sales push back, no, ans push back, and now I'm gonna threatens walls sales, so I put threatens size walls sales return ans. That should work, maybe. Let's run it. Components big comp boom. What? Cannot be narrowed from size type to int. Oh my god, bro, hell nah. Okay, there is some infinite looping. Debug A. Void debug vector int A for auto column in row. So let's do column. So after first you mark the one which threatens most. 1, 2, 3, 4. What? How is that possible? CC in comp CC threatens CC cell size that was comps. I'm not talking at all, but this is just so straightforward, so who cares? First component threatens 4. What? Oh my god. I messed it up. Well, whatever. Okay, now it goes in an infinite cycle for some reason. So you color this, but then it shouldn't be in your components. That is weird. Solved ij. That is weird. Pick 0, 1, 0, 7. And what do you pick here? Oh my days. It should work. It just produces the wrong answer, but oh, because they have to spread. Okay, so threatens actually needs to be threatens. So let's use the size of this. Look at the size of this thing. So every other component needs to grow for comp size, and each component we need to go through its infected cells. So for const auto p in comp I cells, AP first, P second is 1, no, for auto cell in threatens, int I is cell divided by number of columns, and J is cell percentage number of columns, and then row call great. I mean, okay. Should work maybe. Comp I threatens. It's last, okay. Okay, that worked. I can delete this debug code. I don't know, maybe I'm missing something, but from the constraints this should work. This works in n squared m squared time, I guess. Okay, I mean that's kind of for free. Let's see, editorial simulation. Oh, what? That's it? Why is time complexity this? What? Could you see there? Rows and columns. After time t, viral regions that are alive must have a size at least t squared plus t minus 1 squared, so total number of removed across all time is... What the hell? Oh my days. I mean, okay, whatever. It's just simulation, something smarter in the solutions. That is so ugly. What the hell? Why would you write something like that? Easy simulation. Just simulation. Just simulate the process. In each iteration, find the spreading components, calculate for each of them, calculate the walls needed to enclose them, the number of neighboring cells, the number of uninfected neighboring cells, the cells that the component needed for each of them to enclose the component, the cells that the component threatens, the hash set of cells that the component threatens, and the cells of the component itself. We order the components by the size of the threatened cells set and mark the largest components cells by component cells with 2 in the matrix, meaning not spreading. For all the other components, we go over the threatened cells and mark them infected. That is 1. When calculating the components, just pick the spreading components marked with cells marked with 1. Okay. I'm not sure about this one. O of, I mean, let's say you have half of the cells. No, that's not enough. Let's say I have some cells infected, and now when we're gonna run out, well, we do 4 cells. Let's say we have a giant grid and we have 10 of them. Well, after time t, they gonna take up what? 4 plus 8 plus 12. So it's like we are gonna be done by some square root, maybe, because the largest component will fill it up in O of nm per iteration, and there are, so in first iteration, let's say we flood 4 cells, then we flood 8 cells, and blah blah blah. So there will be at most how many iterations? 4 times. So we want to find largest time such that time plus 1 divided by 2 is less than RC. So some square root, maybe, I guess. So, and there iterations will there be. In each iteration we flood at least, in first iteration we flood at least 4. That is so bad. Tilde. No. We flood at least 4 cells. In the second iteration at least 8 cells, blah blah blah. So we are looking for smallest t such that frac t plus 1 divided by 2 lekv nm So we are looking for the smallest solving for t gives us roughly t equals square root of nm. Boom. The final time complexity is therefore worst case nm to frac 32, close the brackets, something like that, I think. Okay, so it's O of nm times nm squared which is equal to this, I think. I guess that works. Space complexity nm, since we store the visited matrix in each iteration and at most all cells in the components in all of the components total, and at most all cells, since we store the visited matrix in each iteration and some of the cells of components found in each iteration is at most nm2. Okay, so that's it for today. I mean, they do a tighter bound, they do 4/3, but who cares? Goodbye.